DHCP, Dynamic Host Configuration Protocol. We use DHCP to assign IP address to um, user automatically. We can even go for manually, but if we have like 300 to 400 users, that time we can't go do configure IP address manually each and everything, and also in manual way it will consume more IP address. That's why we go for DHCP. Suppose I will tell how this work. Like this is a new user. Suppose you take this is a new user, and it doesn't have IP address currently. So it doesn't have IP address, and it doesn't have TCP IP settings. It, uh, it doesn't have TCP IP settings. To access any web pages, it is this these are mandatory get the configuration of this. We will go for DHCP server, where what DHCP server will do. DHCP server will assign the IP address and automatically configure the TCP IP setting so that the user can access the web pages. Okay. Here it follows some process like first what it will first this user will send the discover message. Okay, this user will send the discover message. I will increase the size. First it will send the discover message. Uh, by seeing that discover message, DHCP server will send the offer message. The offer message contains the IP address. Now DHCP server send the offer message. Then again this user will send the request message. User send the request message to DHCP server to it is asking like is it can I use this offered IP address. So then DHCP server will send the acknowledgement message. Yeah. You got it right. First user will send the discover message asking looking for a IP address. Offer message will send the IP address to the user, and again user will send the request message asking whether I can use the offer message. Then DHCP server will send the acknowledgement message saying that you can use that offered IP address, and now the PC can able to access the web pages. Yeah, I will go in a little more depth, like what this discover message contains. What happens exactly here? Like discover message. Um, in a discover message contains operation code. If it's a request, it is 1, and if it's a reply, it is 2. Now, like okay, okay. Now it is sending a discover message. Discover message is a the user is requesting for a IP address. Then it is a request message. So request is equal to 1. Then transaction ID. Eight. Transaction ID is a random 32-bit number. It's a random 32-bit number. So that why we use is whenever it's sending a discover message, it will add this random 32-bit number. When DHCP server reply, it will add the same transaction ID, so that the user will get to know that it is replying for that message. With help of transaction ID, it will get to know. If it's a different transaction ID, it will get to know like this is not the reply for that message. Then flag. Flag is 16 bit, like 15 bits are zeros, and last one bit will be um, uh, 1 if it's a broadcasting. Okay. If it's not broadcasting, it will be 0 only. Since discount message is sending via broadcasting, so last bit will be 1. Then client IP address. Currently, user doesn't have the IP address. That's why I'm requesting it. So currently I don't have IP address. So it will enter 0.0.0.0. Then your IP address field will be there. In your IP address also, it will be filled by DHCP server. Initially, it doesn't have the IP address. So here also it will use 0.0.0.0. Then server IP address. This field will be filled by DHCP server. Currently, we don't know. Then currently we don't know. So it will be like 0.0.0.0. Then gateway IP address. Gateway IP address will take default gateway IP address since DHCP server is within the same subnet. You see, it is DHCP server is within the same subnet. Um, this DHCP server is within the same subnet. So the gateway IP address will be 0.0.0. Then um, client hardware identifier. Here we add the client MAC address. This user MAC address we add. Shit. client MAC address it will add. Then message type, the DHCP, sorry, Discord message type is 1. So it will add the 1, it will fill 1. Okay, these are the essential things I just told. Next, what happens? This whole discover message is encapsulated with transportation protocol. Like here we use UDP as a transportation protocol, where we use source port number in UDP and DHCP, like this is a discover message. So it's a user or port number, means a PC port number. It will be 68, and then destination port number. Destination is DHCP server. So DHCP server port number is 67. Transportation medium, transportation protocol we use transportation protocol, UDP protocol we use. Got it? Then this is encapsulated with IP datagram, like source IP address, source IP address. We take this example, it doesn't have IP address, so we don't know the source IP address, so we take it as 0.0.0.0. And destination IP address. Now, there are in a company there will be many DHCP server. So we do like we do broadcasting so that all the DHCP server will reply. So broadcast means 255.255.255. This network layer is encapsulated with Ethernet layer, where here it will add source MAC address. We know the MAC address of this. We can add, we can fill it, right? So client MAC address it will add. Destination MAC address. Destination MAC address means server MAC address. Since there are many server, we are broadcasting it. So it is like FF, 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 FF. You understand the process, like first discover message contains these many things, and this discover message is encapsulated with the UDP transportation layer. Like so, the source port number, since it is a user port number, client port number, it is 68, and destination port number is 67. DHCP server port number is always 67, and we are using UDP as a transportation protocol. Like why we use UDP? UDP is faster compared to TCP, and suppose if the user didn't get the reply means that's it. It will resend the request. So we don't go for a TCP. We can UDP is faster, so faster and light. So we go for UDP itself. Then source IP address means this UDP is encapsulated with network layer, like source IP address is equal to 0.0.0.0. Why means we don't know the IP address of the user and the destination IP address. Since we are broadcasting it, we want to broadcast this discover message request to all the DHCP servers. So the broadcast IP address will be like 255.255.255.255, and source MAC address is source. Since we know the MAC address of the user, so we can directly enter client MAC address, and destination MAC address we are broadcasting it. Destination MAC address of server, DHCP server, FFFFFF. Okay. Once it once then what how it works? Okay, I will explain here. Um, we mentioned source. First it will go to discover message, will go to switch. In switch, what source MAC address, sorry, destination MAC address, we mentioned it as broadcast, so it will send to all. um, it will send to, it will flood the discover message to all. Based on port number, DHCP server will get to know it is a discover message. It's a DHCP message. So it's a discover message that the DHCP server will get to know this user doesn't have the IP address. So it will check in its um, DHCP pool. Then assign one IP address based on the same subnet. Based on the same subnet, it will assign one IP address. Um, okay, this is the offer message already sent. First is discover message, then second is offer message. DHCP server is sending the offer message. Where operation code will be look here. The DHCP server is replying now, replying the request discover message. So it is a reply. Reply is equal to 2. Then transaction ID. Discover message sent one random 32-bit number. The same 32-bit number it will send. The same 32-bit number. I will write here. Same 32-bit number, and offer message might be unicast or broadcast. Usually it is unicast because it is faster. Unicast means 0. The client IP address is still 0.0.0.0 only, but in Why 0.0.0? Because it's still not confirmed. It's still not started using the IP address. So it is the client IP address will be 0.0.0.0, and your IP address, it will add one DHCP server will give one IP address. Suppose it might be 192.168.20.2. It's just a reference IP address. It can't give any IP address, private IP address. Then server IP address. DHCP server will add the added server IP address. Then gateway IP address. Since this example is based on the same subnet, the DHCP server is located in the same subnet. So the gateway IP address will be 0.0.0.0 only, and client hardware identifier like client MAC address, and type will be 2. For offer message, it is 2. 2 for offer message. Okay. Then along with that, it will add lease time. Lease time is nothing but a duration of which IP address is valid, that it will give. And yeah, server IP address, server IP address. Then yeah, your IP address is filled. Then gateway IP address. Then DNS server IP address. It will fill the DNS server IP address. Why we need a DNS server IP address? To resolve the domain name. If we are checking for a domain name, if we don't know the IP address at that time, it use DNS server IP address. Then subnet mask. It will add the subnet mask. You got it right. What is the least time? Least time is the IP address will have some certain duration. Till that time, the IP address will be valid. That time will be the details will be filled in least time. And DNS server IP address. We need to resolve the domain name, we need a DNS server IP address. So it will fill the DNS server IP address here, and then subnet mask based on the what subnet it is using, the user is using that one. Now again, like now you consider this as a offer message to save time. Like this consider this is a offer message. Like here that this offer message is this offer message is encapsulated along encapsulated with the source port number. The source port number, what is the now a DHCP server is sending the offer message. So DHCP server port number, DHCP server is the source. So DHCP server port number is 67. And destination, now destination is PC. Then the destination port number is 68. Um, now, yeah, now just imagine this is not a discover message, this is a offer message. Okay, yeah, then source IP address is source IP address, DHCP server is sending the offer message. So, yeah, I will write here to avoid the confusion. Now I am discussing about offer message. Source IP address is DHCP server IP address it will use. 1 minute. I will delete everything. So, source IP address is DHCP server IP address. And destination IP address. Destination IP address we don't know currently. Look, DHCP sir offer. I am sending the offer message, and IP address, it still not started using it, so I can't write the IP address. So I will use this broadcast IP address itself, 255 dot 255 dot 255 dot 255. Then source MAC address. This offer message is sent by DHCP server. The source MAC address of DHCP server is, I want to anyhow I know the DHCP server. It will add, DHCP server will add its MAC address here. And destination MAC address. It's understandable, right? Or else- Yeah. Destination MAC address. Destination MAC address. Destination MAC address. I want to send the PC. I already know the PC MAC address, so I can add a user MAC address, client MAC address. What happens here? Since the offer message will go to switch, and switch knows the MAC address, which will do unicast here. Yeah, in some cases it will do broadcast also in rare cases, but unicast is preferred one because it is faster, because it will send only to user, or else it has to send to all the PCs, or the means it will flood, it has to flood. Okay, now offer message is done. Then request message. Need some more space. Okay, now request message. Um, Now PC received the offer message and IP address. Then we'll see. Now this is not a discover message. This is a request message. Request message. Request message like it is sending the request, not reply. If it's this PC is sending the request message, like asking whether I can use the offered IP address. So the operation code will be request one only. Then it will again it will add the random 32-bit number, transaction ID, and flag will be again it's doing a broadcast, so last digit will be 1. Why it's doing DHCP server? Because there will be in a company there will be many DHCP servers and all. It has to reach to all the DHCP server. That time it do like broadcasting, so it will reach the means many all the DHCP server will send the IP address, and the DHCP server should know that which IP address it is selected. So it will do the broadcast. So flag will be like last digit will be 1 only. It's a, then client IP address. Yeah, client IP address 0.0.0.0, because still PC not started using that IP address. Uh, your IP address. Look in discover section. Sorry, in offer section, it has already given the your IP address section, right? So your it will fill the your IP address section. Just for reference, I have taken this IP address. It can give any IP address. It is given by the DHCP server in offer message here. You can see. Then it will mention the DHCP server IP address. It will add the DHCP server IP address, so that all other DHCP server means who and all assign the IP address, what and all, if there is a multiple DHCP server, when it saw the DHCP server IP address, then it will get to know that user that client has accepted IP address from that particular DHCP server. Then gateway IP address, since it is in the same subnet, the gateway IP address will be 0.0.0. And one more thing I forgot to tell, we can configure router as a DHCP server, or L3 switch also as a DHCP server. It will work fine. And gateway IP address 0.0.0. Okay, then client hardware identifier, like client MAC address, and type, this is a request message, right? So the type will be 3. Here the requested IP address will be your IP address. Okay, that a request message is sending to DHCP server. Can I use that IP address? It is requesting. Mm, if I tell here only, you will get confusion, I guess. I'll tell you. Okay. This is a request message. This whole thing is request message. This request message is encapsulated with UDP, transportation protocol. UDP protocol. Um, I will delete all the values. Okay. Source port number. It's requesting the source port number. The source, this is the source. So its port number will be 68. And the destination port, the DHCP is the destination. So destination port number is 67. It uses UDP protocol. Then this transportation layer is encapsulated with a network layer where source IP address is still it's not started using IP address, so it is still 0.0.0.0. Destination IP address. As I told you earlier, that since if there is a multiple DHCP servers and all, it has to send it has to send the request to all the DHCP server, so that the DHCP server which assign the IP address, that is all the DHCP server will assign the IP address, but it will select one IP address which reached earlier. So and it will reject all other IP address. So when it, in server IP address, it will fill the DHCP server IP address, so that other DHCP server will get to know that this has received IP address from this DHCP server. So it will retrieve the assigned IP that the DHCP server will send some IP address, right, at the time of a discover message, that it will retrieve, and it will use that IP address to other user. So destination IP address will be broadcaster, since it is sending to all the DHCP server. In some cases it uses unicast also, but most of the case it will do broadcast. Then source MAC address. Sorry, it always do like broadcast only in request message, that IP address. Switch. Yeah, it is sending from user to DHCP server. So source MAC address will be client MAC address, and um, Those MAC address will be client MAC address, and destination MAC address will be FFFF, since it is sending to all the DHCP servers. Sometimes it will do unicast. Usually do broadcast only. And a little more space. Next is acknowledge message. As I already told, now it is coming from this to this. Like it received the request message, then it will send the acknowledgement message. Like you can use the offered IP address. Now it's doing reply, right? I will take this one. No, okay, this is the acknowledgement message. Um, Acknowledgement message is sending from DHCP server to PC. So it is a reply to the request message. Reply is equal to 2. The transaction ID will be same as the same as the this request message. Transaction ID of the request message. And flag will be acknowledgement message will be usually sent in unicast only, so all the bits will be in 0, 16 bits. Client IP address, client IP address, still the client means use PC clients didn't start to use the IP address, so it will be like 0.0.0.0 only. Then your IP address, it is assigned by offer offer message means it is assigned by DHCP server in offer message, that only it will fill. And server IP address will be the DHCP server IP address it will fill. And gateway IP address will be since it is the same server, since the DHCP server is in the same network, it will be 0.0.0.0. And client hardware identifier, client MAC address it will add. And type 5 is the acknowledgement message. Type 5 is the acknowledgement message. Along with that, it will send like um, lease time, duration of which the IP address is valid, that details. Then server identifier, like a server and gateway IP address, DNS server IP address. In server identifier, server IP address will be mentioned, and subnet mask and gateway IP address. This acknowledgement message. This acknowledgement message source first. Acknowledgement message is sent by DHCP server. So the DHCP server port number is 67 and your client port number is 68. This acknowledgement message is encapsulated with UDP protocol and this the source port number will be 67 and destination port number will be 68 and the source IP address is like source IP address DHCP server IP address it will add. And destination IP address. Destination still this client is not started using IP address, so it uses 255.255.255 only. And source MAC address DHCP DHCP server MAC address will be there, so it will add a DHCP server MAC address. It will add a server MAC address and acknowledgement message destination MAC address. Since it knows the PC MAC address, it will directly send to PC. Where I mentioned. Oh, sorry. This is acknowledgement message. So source MAC address will be like server MAC address. And destination MAC address is client MAC address. Here it does unicast. In rare cases, it will do um, broadcasting, but usually it do acknowledgement message will be client unicast, so that it will faster. Unicast will be faster. Okay, you got it. This I explained if the DHCP server is in same subnet. Suppose if this is the case, like DHCP server is in the different network. At that time, what happens? Like it will add the gateway instead of 0.0.0, it will add the default gateway. Discover message will add the default gateway IP address. Rest of the process is same. Like once it at the once it comes the look we call in DHCP we call the router as a relay agent. Like it the router which acts as a middleman, that we call it as a relay agent, a middleman between PC and DHCP server. The router which acts as a middleman between client and DHCP server. It is known as relay agent. Got it? Okay. One more thing I want to say, like Discord message, as earlier I told that where it is. Discover message that destination IP address will be 255.255.255.255 and destination MAC address will be FFFFFFF. So what happens here? What happens here? The discover message, yeah, discover message will go here and it will flood everywhere. But once it's reached the relay agent, it will do unicast only. It will do unicast. Even though the network IP address is 255.255.255, the destination IP address is 255.255, which means broadcast. But since this relay agent will know that based on the port number, it get to know that this is a discover message, so I have to do the unicast. Since the relay agent knows the DHCP server IP address, so it will directly send to send the discover message to the DHCP server. Since it is unicast. Here it is broadcast. Here it will be broadcast. Then then again offer message, like in offer message also it will add default gateway IP address of the client. Now I'm not talking about same subnet. Now I'm talking about the router which is in the DHCP server which is in the different subnet. That time the gateway IP address will be default gateway IP address of client. default IP address of the client it will add up, and rest is same. Offer message also it will go from DHCP server, it will go unicast. From year to year it will go unicast. Then yeah, offer message usually do unicast only here. Here also, here also it will be unicast only. Look, offer message here also it will do unicast only. Like directly it will send to here. Since the MAC address will be known, so it will directly unicast. In some rare cases, it will do broadcast. Then the request message. Yeah, everywhere like gateway IP address will become a default gateway IP address. Request message will be sent by PC. Request message will be like broadcast, right? Look, destination will be broadcast. FFF. So request message will till I will tell you till here it will go broadcast. Okay, request message till here from here it will go to switch, and switch will broadcast to every places, and from relay agent it will do unicast. Then again acknowledgement message gateway IP address will be default gateway IP address. Um, yeah, acknowledgement message will be sent unicast only. From here also it will since the MAC address of yeah, since the MAC address of uh, client it knows, so directly here also it will do the unicast only in acknowledgement message. Okay. In this way, the DHCP process will work, and there are um, some important points I didn't told, like um, suppose Here I will tell. DHCP, this PC sent a request message, and now DHCP server has to send the acknowledgement message. But if the DHCP server finds out that the assigned that offered IP address is given to other client, means other user, then it will send the DHCP negative acknowledgement message. You understand? You got it right? Like if a PC receive the offer message, and this client will send the request message, and the suppose if the DHCP server find out that the requested IP address contain that requested IP address was already using by some other user, then it will send the DHCP negative acknowledgement message, and DHCP decline message. Suppose this client got to know that it is using the IP address which is already used by another client using app request. So that time it will send the this client will send the DHCP decline message. This message it will send to DHCP server, and DHCP release message. DHCP release message will be sent on two cases. If the device is shutting down, or restarting, or if a device moved to another subnet. DHCP release message, I will tell. If this device is shutting down or restarting, at that time what it will do, it will send one DHCP release message to DHCP server. What it indicates that this release the IP address. Release the IP address that is assigned to me, and cancel the lease IP address. Cancel the lease time. Cancel the remaining lease time. You got it. Now currently it is using one IP address. Okay. This device is shutting down or restarting. At that time it will send one release message to DHCP server saying that release the IP address which is assigned to me, and cancel the list remaining list time. DHCP server, what it will do, it will send the acknowledgement message. DHCP server will send the acknowledgement message to your client, so that it will get to know that the this IP address, it can be given the the IP address which is used by client, it can be offered to another client the same IP address can be reused. Suppose, and one more thing is, when it moved to another subnet, suppose if this PC is moved to different subnet, this PC moved to different subnet here. At that time, the IP address what it was using, it is of no use. At that time, what it will do, it will send the release message, the saying that release the IP address. That time also release the IP address and cancel the remaining lease time. That time also, what DHCP server will do, it will send one acknowledgement message to the client, and it will retrieve the IP address from what the client was using, and it will use that IP address to I use that IP address for another client. And DHCP inform message. DHCP inform message, suppose if you assign the IP address manually, if you assign the IP address manually, that time, but still you need some configuration like TCP/IP settings to TCP/IP settings to access the web page. So what it will do, it will send the what it will do, or it will send the one inform message to DHCP server. DHCP server um, DHCP server will automatically configure the TCP settings, but while but it will in your IP address, it will not add anything, since it is using manual IP address. Since it is using manual IP address, so it will um, since it is using manual IP address, so it will not add in your IP address field, it will not add any IP address. And in a DHCP not acknowledgement message, Yeah. Suppose DHCP server IP pool is finished, means it exhausted, or it has given all the IP address to the client, and one more client is you are requesting for the IP address. It is sending the discover message. That time, what it will do? It will send the DHCP not acknowledged message. Um, so once that may, once that message reached to client got to know that the DHCP message is sorry, the IP address is exhausted. So it might use APIPA. APIPA, like it will assign IP address like 169 dot 54 dot 0 dot 0 to 169. Yeah, till this range that APIPA can be used. But this allows limited local connectivity, but no internet access. No internet access, but limited int- connectivity. It will get limited local connectivity. For use of limited local connectivity, we can do. Okay, that's all about DHCP.